Earth itself is a huge magnet. This animation depicts Earth's magnetic field lines as viewed from outer space. This is Earth's magnetosphere. Its magnetic field is similar to that of a bar magnet. But you'll notice that the field lines far away from Earth, they bend away. This is due to the ionized solar wind from the sun that encounters Earth. As we discuss elsewhere, Earth's magnetosphere acts as a shield, protecting us from this energetic solar wind. The source of Earth's magnetism is still not completely understood. Most investigators, however, attribute the field to convection currents within Earth's interior. What we do know is that the direction and strength of Earth's magnetic field changes over time. Let's explore this. First, if you hold a compass at either Earth's north or south magnetic pole, the needle would face vertically, straight up and down. Earth's magnetic pole is located where the magnetic field lines are perpendicular to Earth's surface. Earth, however, it's a complicated and rather dynamic planet. Because of this, the magnetic poles are not necessarily fixed at the same location. We find that the magnetic poles tend to wander. Here's a map showing the location of the northern magnetic pole over the past few centuries. As of 2020, the Earth's magnetic pole in the northern hemisphere is slowly moving on a path from Arctic Canada to northern Siberia. As shown on this magnetic declination map, the magnetic field lines along Earth's surface don't always point to the magnetic poles. This map is useful in navigation to show how far off your compass is reading from the geographic pole. Of course, because Earth is a complicated and dynamic planet, these declination maps always need to be updated. Today, however, navigation is done primarily through our network of global positioning satellites, also known as GPS. Now, zoom out to a planetary point of view, and you'll see the field lines appear to merge at a location that is actually different from the magnetic poles. This broad-scale view of a magnetic pole is called the geomagnetic pole. I know. Geomagnetic pole sounds an awful lot like magnetic pole, but there's a difference. The magnetic pole is located where a compass points in a direction perpendicular to the surface, straight up and down. The geomagnetic pole is like the average of all the variations found across the planet. It's what ions from outer space encounter, which is why the aurora are generally centered about the geomagnetic poles. The northern geomagnetic pole is currently somewhere over Ellesmere Island in northern Canada, which is different from the location of the magnetic pole, which of course is different from the geographic pole. Here's another fun fact. The geomagnetic poles are not currently aligned to the geographic poles, true, but over thousands of years, they migrate around the geographic poles. Average out the positions of the geomagnetic poles over thousands of years, and you'll find you've got the position of the geographic pole. That's interesting. Even more interesting, the magnetic poles sometimes flip orientation. North becomes south and south becomes north. How do we know this? The most direct evidence comes from ocean seafloors. As parts of the floor spread apart, metal containing molten rock solidifies and thereby captures the orientation of the magnetic poles at that time. Studies of the ocean floors show bands where the magnetic orientation of minerals making up the floor are flipped in the same way on opposite sides of the ocean ridge. This allows us to date the timing of magnetic reversals, the last one occurring about 700,000 years ago. But does the magnetic field disappear during a reversal? Geologic records show that past reversals have had no significant impact on life forms. This suggests that while the magnetic field might weaken during a flip, enough remains to deflect solar winds. Geologic records also show that a reversal only takes hundreds or thousands of years to occur, which is rather quick on geological timescales. The next magnetic reversal, it could happen any time. But for now, you can rest easy in your appreciation of Earth's dynamic magnetic field. Good energy.